Artistic recoloring of image oversegmentations. An oversegmentation can divide the image into many small regions. We provide an automatic recoloring algorithm that can generate colorful abstractions from an oversegmented image. Using a highly detailed oversegmentation, we can produce interesting results. We have been inspired by colorful representational images, where artists had the freedom to use arbitrary and vivid colors to express the image content. To show the structures in the image, it is important to preserve the strong edges. We also want the recolored images from our design can clearly show recognizable objects in the image. In this work, we designed a recoloring method for an oversegmented image that can create wide abstractions with just one palette. We also created various styles by a color blending mechanism and applying different metrics. We input a set of regions from an oversegmented image and a color palette to the algorithm, and compute color differences for the image and for the palette. We then create a tree on the regions of the segmented image to be able to organize the color assignments. For a better use of the palette, we histogram match the color differences in the image with the color differences in the palette. Finally, we traverse the tree and recolor the segments. The color assignment tries to match the color differences in the image as closely as possible with the differences in the palette. Our input is an oversegmented image and a palette. We compute color differences between adjacent regions, giving us delta Q. We also calculate the color differences between all palette colors, producing delta P. We plan to match the color distances delta Q and delta P. We create a tree over the input oversegmentation using the widest pass algorithm. Edge weights are computed based on both color difference and region size. Considering the color differences in edge weight calculation ensure that the widest pass tree links the similar regions and result in good edge preservation. We also preserve small color distances by assigning large edge weights to small color differences. We want to make use of the full palette, which might not happen if we directly try to match the color distances. We apply histogram matching, which gives us a new target color difference for each edge of the graph. And it ensures that the distribution of the target values is the same as the distribution of values in palette color differences. We now traverse the tree and assign the colors. We begin by assigning the closest palette color to the tree's root node, and then repeatedly select a color from the palette for the current region, based on the target color difference to the parent's assigned color. Here are some results. We maintain edges. Objects are visible and flat regions are broken up into colorful regions. We tried blending to produce smooth color transitions. We cross-filtered our result with an edge over filter, and recolored images are now more painterly. You get different results depending on the color spaces used for the distances. Sometimes our method shows problems. Different colors might be assigned to similar regions. For example, different parts of the sky could be colored differently, which doesn't look good. Also, spurious edges might appear. Also, if we use a palette with close transitions between colors, it can partly fix this issue. In summary, we propose a graph-based recoloring method for oversegmented images using different palettes. Designing our algorithm with the widest pass allowed us to maintain objects' recognizability. We achieved various recoloring effects using a blending mechanism and different choice of distance metrics. Thank you.